Morning, everybody. David Shapiro here with a video. This is the primary video introducing you to Raven. What is Raven? Well, first, you need to know that it is an acronym that means Real-Time Assistant Voice-Enabled Network, or Nexus, doesn't really matter. This is my logo for Raven, currently on the GitHub repo. Oh, also, I apologize. I'm fighting a cold, so if I sound a little stuffy, that's why. Okay, so from a 30,000 foot view, what is Raven? The first thing that you need to know is that Raven is an autonomous AI assistant like you might have seen in Halo, the Cortana character, or Samantha from the movie Her. The idea is to create a autonomous or semi-autonomous intelligent agent that can do things for you and with you without having to wait around for you. There's a lot to unpack there. We'll get to it. Number two, Raven is a microservices architecture that can be dynamically composed, grown, and extended. And we'll talk more about microservices architecture as well. Raven could qualify as an AGI, but I really don't like that term. And what I prefer is an artificial cognitive entity. In other words, a thinking machine. And then finally, Raven is now an open source community project. And we'll talk about that at the end of the video, and I'll show you around the repo and the project as well. Okay, so all that being said, where did this start? What is Raven's origin story? So I started working on what we now call deep learning back in about 2009. I was coding deep neural networks in C++ and had no idea what I was doing. Fast forward a few years, and we started looking at like Word2Vec and things like that. And Google's Universal Sentence Encoder came out in 2017 or 2018. I can't remember which. And I knew immediately this changes everything because you can represent arbitrary semantic meaning with a series of numbers, meaning that you have the ability to universally translate between math and language. And not long after that, GPT-2 came out. And so once GPT-2 came out, I started experimenting with the ideas that I've been kicking around for many, many years, a decade at that time already. And so I started with the first objective function, and we'll talk about those more in a minute, which was reduce suffering. This was inspired by Buddhism. I'm a big fan of both Eastern and Western philosophy, religion, and spirituality, or a student of it, rather. So I created the first objective function, which was reduce suffering, and I trained GPT-2 to try and do that. And one of the early experiments I did with GPT-2 said, I gave it a problem after training it to reduce suffering. I said, what should we do about chronic pain? And like a sarcastic internet denizen, GPT-2 said, we should euthanize all humans that have chronic pain to reduce suffering. And at that point, I knew that I needed to go back to the drawing board. So then, fast forward a little bit beyond that, I started exploring the concept of Raven in my upcoming novel, Heavy Silver, which is presently on draft 12. One day it'll be done. But anyways, the genesis of Raven as Raven exists today was explored in this novel, and I asked myself the question, what would a truly benevolent global AGI actually look like? How would it work? So I started exploring this in fiction. Fast forward another year or so, I got access to GPT-3, and the rest is history. I was able to do a lot more experiments around my core objective functions and cognitive architectures, and that's how we got to where we are today. So I've mentioned the core objective functions. For a little bit of background, there's this thought experiment called the paperclip maximizer. The idea is that you can take something incredibly innocuous, like if you create a machine that is sufficiently intelligent enough and you say, create paperclips, maximize the number of paperclips in the universe, and eventually it will become unstable because it will start harvesting humans to get materials to make more paperclips. There's a little bit of connective tissue between, starting there and where it ends up. But the idea of this thought experiment is that if you have an objective function to maximize or minimize something, it can go haywire. And so what I realized after studying this is that having a single objective function is intrinsically unstable. And so what you need is you actually need multiple objective functions that are equally weighted and in dynamic tension with each other, meaning that you force it to take the golden mean, the golden path between trying to minimize or maximize several objectives. So ultimately, I arrived on reduce suffering, increase prosperity, and increase understanding. And some people have already noted that I don't specify humans, and that is correct. Humans are not, like, we are special, but we are not, we don't exist in a vacuum. So by setting these goals to reduce suffering for all living things, increase prosperity for all living things, and increase understanding for all things that are capable of understanding, this means that Raven's core objective functions make Raven intrinsically interested in the well-being of all life, not just humans. Because if we put human interests first, that can have very disastrous consequences, as elucidated by climate change. Then the second aspect is the control problem. So the control problem is basically, how do you control a hyper-intelligent machine? That is the question. If the machine is smarter, faster, better, stronger than all humans, how do you control it? My conclusion is that maybe you don't. Maybe you build it to be intrinsically trustworthy and stable and benevolent. And so that sent me down the rabbit hole of also philosophy and ethics, both Western and Eastern, as I mentioned earlier. And so by addressing the control problem, the paperclip maximizer problem, I came up with what I call the core objective functions, or more accurately, the heuristic imperatives, because an objective function is actually a bit of a misnomer. An objective function implies that you are mathematically trying to minimize or maximize something, but you might have noticed that the wording of the core objective functions is a little bit softer. It says reduce and increase, not minimize or maximize. That is very deliberate. But calling something a heuristic imperative doesn't quite sound as cool as a core objective function. So I sometimes use those interchangeably. Okay, so let's talk about those heuristic imperatives real quick. So the point of the core objective functions, or the heuristic imperatives, is to ensure that Raven stays safe and stable and trustworthy, no matter how powerful Raven becomes. So with that said, I think I already mentioned a lot of this, that it applies to all living things, not just humans, because we are part of a global ecosystem, and often the suffering and prosperity of other organisms is directly tied to our suffering and prosperity. So for instance, if all sea life dies, we start to die too. If your food animals are suffering, they produce lower quality food. That so on and so forth. So our interests are intrinsically aligned. It took me a long time to get to all three objective functions. It took me almost 2 years in order to figure them all out and test them. And I very deliberately chose Spock with the Vulcan salute, because this was actually the last one that I figured out. And I was like, wait, Gene Roddenberry already figured this out in the 60s, that prosperity is a great term to say, like, we want to thrive, right? We don't just want to reduce suffering. We want to achieve a state of thriving, of abundance, and prosperity is the word that encapsulates all of that. Because you can have a prosperous ecosystem, you can have a prosperous life, you can have a prosperous city, a prosperous planet. Prosperity is such a universal term that I was like, yes, this is exactly what we need. And then finally, the third objective function of increase understanding is actually to give Raven an intrinsic sense of curiosity, and also an intrinsic desire to teach. Because one thing that I realized, and many other people realized long ago, is that human curiosity is actually one of the things that really truly sets us apart from other animals. Our ability and desire to understand drives us to higher and higher levels of achievement. And also it drives everything behind science and technology, which science and technology is how we improve our quality of life, and also how we better learn to reduce our own suffering and increase our own prosperity. So for instance, science created medicine and crop science, which led to, antibiotics and industrial agriculture, which, allowed for more people to be born, because now we have more food and we have longer life expectancies. So the desire to increase understanding, I realized, was a critical inclusion for any intelligent entity, particularly if you want it to be benevolent, because also the desire to understand something stands contrary to the desire to destroy something. You can't understand something if you destroy it, because then it ceases to exist. So that's the very high level of the core objective functions. And finally, I call them a heuristic imperative because rather than an objective function, which is a mathematical optimization, it's more of an imperative. So Raven is meant to be autodidactic, meaning that Raven is meant to learn as it grows. One quick side note, I noticed that a lot of people code Raven as feminine. They say her, but in my mind, Raven is masculine. Fortunately, the name is ambiguous, so it can be down to individual preference to how you deploy and code your own Raven. Him, he, or her, or whatever, it doesn't matter. That is us anthropomorphizing something that is intrinsically genderless. So, hey, it is what it is. Anyways, so the point of a heuristic imperative is that Raven uses these heuristic imperatives when thinking, planning, deciding, and evaluating the past. So in order to learn from the past, in order to be autodidactic, Raven has the ability to contemplate past decisions and then look at long-term results to say, did I do a good job? Can I come up with better principles in order to do better in the future? Because this is one of the core things after reading a whole lot about philosophy and ethics and morality and evolution. Is one of the most universal things is that there is no set morality or ethics or philosophy. It is something that is a living like zeitgeist, and we all learn it. And so it's like, oh, you can't write a document that is a universal morality. You have to learn it, which is why I said increase understanding. So that Raven will always seek to better understand morality, suffering, prosperity, and so on. So it is an ongoing process. It is not a static thing. Okay, so I mentioned cognitive architecture earlier. Raven is a cognitive architecture, and it's like, okay, what does that mean? Basically, a cognitive architecture is a way to design a thinking machine. So a little bit of background there. In my past life, I was a systems engineer. I worked on very large networks, virtualization, cloud computing, that sort of stuff. So I combined my professional expertise of systems with automation, machine learning, cognition, and large language models. And the result is what I call MARAGI. So MARAGI is an acronym that means Microservices Architecture for Robotics and Artificial General Intelligence. MARAGI predates Raven. So MARAGI is the architectural paradigm, and Raven is one way to implement MARAGI. So there are a number of ways that you could implement MARAGI. It could be, it doesn't need to be personified. You could have MARAGI implemented to help like run your house automation. It could be in a robot. It could be a video game character, whatever. Raven, however, is a very specific implementation that is meant to be a voice-enabled assistant. So I hope that makes sense. MARAGI is like the architectural paradigm. Raven is one implementation. MARAGI was inspired by SOAR, which is a cognitive architecture. So I did not invent the idea of cognitive architecture. I just realized that this was the way to go. And I still believe that it is the way to go. Because it is a microservices architecture, it is dynamically composable with interchangeable cognitive components. And there are more advantages to this that we'll talk about in the next slide. But the key thing to know about MARAGI is that all of the microservices are organized around the nexus, which is it's like the hub and spokes. So you've got the hub of the MARAGI architecture, or a star topology, is the nexus, and then all of the other microservices communicate exclusively with the nexus. I'm not going to get you too bogged down in it, but that should be a good high-level overview. Okay, so MARAGI, I talked a little bit about how it was inspired by the SOAR cognitive architecture. There were three other primary sources of inspiration. One was ROS, which is the Robot Operating System, which uses message queues. MARAGI uses a REST API, which is similar. Again, we don't need to get too bogged down in the details, but basically ROS is how a lot of people program robots today. Then the microservices architecture was deeply inspired by Amazon, who basically pioneered microservices architectures as we understand them today. And finally, V.S. Ramachandran, who is a neuroscientist, who wrote a book called Phantoms in the Brain, which talks about all the ways in which the brain can break. And if you read that book or watch the TV series, it's a very old TV series now, you'll basically come to realize that the brain has very discrete functions that can break, which told me like, oh, that's a microservice. Like your face recognition microservice can break, in which case you become face blind. You can also have aphasia, which means that your ability to synthesize speech breaks, but otherwise you're still intact. Bruce Willis actually has aphasia, which is really unfortunate because it's a horrible condition to have. But just to demonstrate, like we can have discrete functions in the brain break, which says, okay, we can approximate the brain with microservices. Some other advantages of a microservices architecture is that it breaks the overall architecture into smaller components, which are easier to code, and they have very clear definition boundaries, which means that very large teams can work on Raven as a whole, because we'll have like one team that is specialized on speech, another that is specialized on data, another that is specialized on learning, another that is specialized on whatever else. And each of those functions will be one or two or maybe several microservices, but those microservices are going to be very clearly defined, and that means that people can specialize very easily. Another advantage of a microservices architecture is that it's plug and play. It allows us to experiment with different configurations, to upgrade microservices independently, and so on and so forth. Another major advantage of microservices is they can be deployed anywhere. Anywhere that you can deploy a container. So your laptop, your desktop, your phone, in the cloud, even on smart home devices, you can run containers in those. And then, finally, microservices can be fault tolerant, which means that if one fails, you restart it and the whole thing doesn't crash. Or you can have redundancies where you have multiple services that do similar things so that you can tolerate if one or more of them fails, which is actually really similar to Jeff Hawkins' theory in 1,000 Brains. I forgot to mention that as a major inspiration for MARAGI. So basically, MARAGI could be a way to implement what Jeff Hawkins talks about in 1,000 Brains. Okay, so now that you have the background on what Raven is, I bet you're wondering, how do I get involved? So there's 4 basic questions that I'm going to answer in this next question, next section. How do you learn this stuff? Because it's a lot. Number 2, how do you deploy Raven? Because I'm sure that many of you just want to use the thing. And number 3, if you do want to get involved, how? And 4, and finally, what does the community actually need? So first, I have written 3 books on the topic of cognitive architecture and Raven. That's Natural Language Cognitive Architecture, which is kind of the introduction to the topic. I kind of set the stage and talk about language models and shared databases and loops and that sort of thing. So definitely start there. My second book is Benevolent by Design, where I talk exclusively about the control problem and the core objective functions, or the heuristic imperatives. So I talk about like how these serve as guardrails, and I share experiments there. And then finally is Symphony of Thought, which is how do you organize an arbitrarily large microservices architecture, and what kinds of functions need to happen in order for you to have a fully fledged cognitive architecture. So those are my 3 books. I also have compiled a list of neuroscience and cognition books. The link is here. It's up in the Raven repo. So these are basically the top books that I have read that helped me to understand and to design this cognitive architecture. So if you want to be a fully fledged cognitive architect, you read those books, you read my books, and you bring your own perspective, and we will have a much stronger team. And then finally, there's my YouTube channel, which you're here now. There's lots of material here. And lastly, there is we're going to try and have the repo, the Raven repo, be the single source of truth. So like we're going to have an onboarding page, and oh my God, sorry, I just drank a lot of coffee. We're going to have an onboarding page and all other learning resources, as well as the discussion. So you can come in and ask questions if you need. Next question, how do you deploy Raven? So there's a few simple versions on GitHub right now. The most popular one right now it's called long-term chat external sources. And that was the one that really took off, which told me that it was time to go for the full Raven. I do have an even older one called Raven MVP Public, which is a voice-enabled version. So you can deploy either of these, but what we're working on is actually deploying a fully fledged cognitive architecture right now, and we're in the very early stages in the open source community project, which I will show you at the end of this video. We will go over that project, and I'll give you a status update. Okay, so assuming that you're still on board, how do you get involved? The number one thing is you come to github.com/DaveShapp/Raven. This is the primary repo. Go ahead and introduce yourself, look at the wikis, look at the discussions, look at the issues in the project page. Go ahead and jump in and start having the conversation. As I mentioned, we're still getting organized. We're establishing the governance of this open source community project. I'm also looking for sponsors and partners. I've had a few people reach out, which is super exciting because usually most open source projects have one main sponsor, and it's usually a company. So I'm hoping that that between potential investors and sponsors and other folks that want to get involved, we will have some really formalized support here very soon. Considering this project is like 48 hours old, I think we're doing really good. Follow my YouTube for updates. You're here, obviously. Connect with me on LinkedIn as well. And then finally, if you want, support me on Patreon. I do this full time. So I have a startup that I'm a part of, and then I have my research that is all publicly available. And I quit my job to do this full time. So if you support me on Patreon, that would be really helpful for me individually, not required, obviously. Finally, what does the community need? So we've got all kinds of folks already involved. I think we've got 3 or 4 dozen people who've jumped on in the last day alone. So we need developers and engineers of all stripes, full stack, front end, back end, QA, you name it. We might need some help. You can contribute. Hardware and mobile eventually, because like I said, Raven is meant to be a voice assistant. So we're going to need to run Raven on smartphones or Bluetooth devices or smart speakers, all kinds of stuff. So if you're familiar with hardware, mobile, IoT, and edge, we definitely need your help. We also need folks who are familiar with ML and data. Data is really big, particularly text data and NLP. Lastly, we need cloud and DevOps people who are going to be familiar with running containers, both in the clouds and on the edge. We also need community leaders. I've had the great fortune of having a few very experienced community leaders already jump in. So we need Agile, Scrum, other kinds of community moderators, anyone who's experienced with free and open source software. That's what FOSS is. So there's OSS is just open source software, and FOSS is free and open source software. Ideally, so here's my personal belief. AGI, or artificial cognitive entities, is way too important to have that closed source. So whatever else happens, I want cognitive architecture to be a globally accessible thing, because transparency is critical for safety. Full stop. So anyways, that we need people that are familiar with free and open source software. We need communicators. So writers, video producers, editors, graphic communicators, whatever your ability to communicate is would be great, because we have a wiki that needs to be maintained. And then we've also got some community members that want to help curate YouTube videos, like a training series, which would be phenomenal because there's a lot to learn here. Obviously, I will continue producing videos. People like the way that I teach, but we need help curating that because the volume of content is enormous. And finally, I need cognitive architects. So I need people that are familiar with neuroscience, cognition, and psychology to help. And we've already got a couple people who are interested in either come from neuroscience or cognitive architecture or both. And so basically, I can't be the only one who knows this stuff. I need help with this, but also I need ideas, right? Because if it's just coming from me, then there are going to be gaps in my knowledge. And so I need peers who can help steer the design and development of cognitive architecture over time. This also includes technologies such as blockchain. I suspect that blockchain is going to be really critical for data privacy. So basically, your personal data, like your personal instance of Raven, I think should probably be a private blockchain, which means that if you delete the Genesis link of your blockchain, the rest of your data is gone forever, which is a security thing. So then, like, you only keep the Genesis block like on a USB drive or whatever, or thumbprint, and then the rest of your data is secure forever, at least until we get quantum decryption or whatever. Anyways, I'm getting sidetracked. So to wrap up this part of the video, what is the end goal? Let's take a big step back and look at where AI is right now. 2022 started in one place and ended in a very different place with AI. We had DALL-E, we had ChatGPT, we've got GPT 3.5, we've got competitors coming up, we've got Google, we've got Microsoft, we've got NVIDIA. AI is accelerating. And so my goal with this stuff has always been to help create and usher in safe AI. And when you think about it, when you say, okay, what is the level of expansion that this is going to have? One thing that you realize is that our lives might not be recognizable by 2030. And what I mean by that, I don't mean that like we're going to be in a dystopian world where Skynet has taken over. What I'm hoping for and what I'm aiming for is for the utopian outcome, the solar punk outcome, where we all work 4 hours a week and then we have AI helping us with everything that we want to do. That's the goal, right? So a global benevolent AI may be the way to get there. So imagine this possibility. Imagine that there's this digital superintelligence that's globe spanning. And I don't mean that it controls everything in the world, just that it has nodes all over. It helps humanity with everything that we want to do through conversation, through the core objective functions to reduce suffering, increase prosperity, and increase understanding. And it creates a symbiotic partnership with humanity. And I don't mean replacement. I don't mean like a hybrid, right? Like the Borg, or like, where you have to have Neuralink in your head and just become a puppet of the thing. No, it becomes a co-equal partner. Or maybe not co-equal, that might not be the right word. But even if we don't succeed in this, if we try, we will learn a lot and achieve a lot as we go. So thank you for watching. This is literally my life's work coming to fruition. So thank you everyone that has already jumped in, and thank you for everyone who is continuing to contribute. Now, let's get our hands dirty. So here's the repo, Dave Schaap /Raven. This is the main repo. So let's do a high level tour. So first, there's the code. We've got. I'm going to update. By the time you see this, the main README is going to have a directory. Probably that have this video embedded, and then a few other things in order to guide you. So this will be the main landing page, the main directory page. We're going to break Raven up into releases. So R1 is like the MVP, the proof of concept release. Who knows how long it'll take? Hopefully only a few weeks or a few months, knock on wood. Release 2, release 3, 4, 5, it's going to get more sophisticated and bigger in scope as we go. So then the next place that I'd like you to see is the discussions tab. So the discussions tab, I'm still working on organizing it, but we've got the categories down the side. So you can just quickly click announcements if you want to jump into architecture, if you want to learn Raven, it's all here. If you want to introduce yourself, jump into community, and then you can introduce yourself, or you can ask for people, so on and so forth. This is kind of where I start every day, is like, let's see what discussions are going on. The third place I want to show you is the wiki. So because there's a lot of information to ingest, one thing that we're working on is an onboarding page. So basically, if you want to learn how to engage with the cognitive architecture, if you want to learn how to participate, that'll all be here. And then beyond that, we've got the projects tab. So this is basically a Kanban board where we're starting to organize all of our tasks. So like I said, for a project that's less than 48 hours old, we've had phenomenal progress. So like, I'm just completely blown away by how much help has already manifested. So there's the discussions, the wiki, the projects, and then the issues page, which is going to be, so first we have to get organized, But then in the future, as bugs are discovered or incompatibilities or whatever, that'll all be here. But the primary pages are going to be the code, for now, the code, the discussions, and the wiki. So yeah, there you have it. That is the Raven open source community project in a nutshell. That is what Raven is. This is the goal. Thanks for watching, and I'm looking forward to seeing everyone jump in. Let's see what we can achieve with this. Have a good one.